We know that the Sahara Desert is the largest hot desert in the planet. But what if I told you Sahara was once a grassland, full of plants and trees? How did it transform from a grassland to a desert? Located on the African continent, with an area of 9,200,000 square kilometers, Sahara is the largest hot desert in the world and the third largest desert after Antarctica and the Arctic. Today the desert is defined by huge sand dunes, blazing hot sun and the oppressive heat. But thousands of years ago, things were not the same. According to researchers, the Sahara had shifted from wet to dry climate over the past thousands of years. The main reason behind this change of climate is the Milankovitch Cycle. The Milankovitch Cycle is a periodical movement related to the Earth's movement around the Sun. There are three types of cycles in a Milankovitch cycle: eccentricity, obliquity, and precession. The change in shape of Earth's orbit is known as eccentricity. A change in the tilt of the Earth's axis is known as obliquity, and a wobble of the Earth's axis is known as precession cycle. All three of these orbital cycles impacts African climate on a longer timescale, but the cycle with the most influence on the rains in Africa is the precession cycle, or the wobble cycle. Researchers have analyzed dust deposits of the coast of West Africa over the last 240,000 years and found that the Sahara and North Africa in general had swung between wet and dry climate every 20,000 years. Orbital precession greatly influences North African climate because it controls the strength and northward penetration of the monsoonal rains. A slight wobble in the tilt of the Earth's orbital axis allows it to receive maximum sunlight during the summers. Strengthening summer season increases solar radiation, which causes the North African landmass to heat up. The warmer landmass then creates a broad low-pressure zone, driving the inflow of moist air from the tropical Atlantic, which ultimately causes the summer monsoonal rains. Likewise, when the planet's axis swings towards an angle that reduces the amount of incoming summer sunlight, monsoon activity weakens around the region, ultimately causing a drier climate similar to what we see today. Some researchers also suggest that overgrazing of animals by humans might be the reason behind the desertification of the land. At some point of time I will make a detailed video about the Milankovitch cycle and the Ice Age, so make sure you are subscribed to my channel and press the bell icon to receive all the updates from my channel. So when is the desert turning green again? According to a new study, parts of the desert can already be made green again by setting up massive solar and wind farms, which will cost a huge sum of money. But it will take another 15,000 years to complete the precession cycle and turn the whole desert green again. Humans might be long gone away from Earth by that time period. That's all for the video. Hope you learned something new today. See you next time.